panel is new features for new markets. And you know we're going to get into some serious stuff and be technical because I have my reading glasses on so I can make sure I'm capturing my notes correctly. It's great to be with you today. I am with my esteemed panelists who are from multiple different companies that are focused on these issues and are doing spectacular things in this space. So this is a 90-minute session. The last session I did was 30 minutes, so we kind of jumped right into it. So I really want to give them 5 to 10 minutes to talk about who they are, what they're doing, and how they're revolutionizing, and they're going to revolutionize 6G. I think it's important to kind of grasp and get your arms wrapped around what they're doing, and then we move into the Q&A portion of this panel, and then I also want to open it up to the audience as well. So if you have questions, jot them down. You will have an opportunity to ask them. So Ray, why don't you jumpstart the conversation, talk a little bit about what you're doing at Cohere and how you are revolutionizing 6G.
Great. Well, thanks, Diane. So I joined Cohere actually in 2018 as the CEO. The company was founded back in 2011 actually by two visionary founders, Shlomo Rakib and Roni Hadani. Shlomo is a serial cable entrepreneur in the access space and Roni a professor. And what they decided was to pioneer this notion of a new domain beyond time frequency. It's called delayed Doppler. It's very familiar to radar engineers, not so much to communication engineers. And the theory was that if you transform the channel through FFTs from time to delta time and frequency to delta frequency, you'd be able to unlock a lot of the complexity and take the industry to the next level. We pitched that solution. It was called OTFS, for orthogonal time, frequency, and space. Pitched it to 3GPP in 2016-17, lost that major battle. And so I joined in 2018, and what we've been doing since then is we took the solution into two pieces. I'm not going to get into the technical details now, but one is a channel sensing and prediction engine. I talked a little bit about that earlier on the panel, about how it's making 4G and 5G better. And we maintained a candidate for what we hope is at least one of the waveform options in 6G, which is an OTFS waveform. So think of us as commercializing the USM in real time right now in partnership with other large companies and with the support of operators, mostly focused on spectral efficiency, making networks better and more efficient in 4G and 5G, and then having an option for new waveform. And when we talk about things like integrated sensing and communications, and we talk about some of the vertical industries like the defense industry that Mark and Lockheed are involved in, we'll talk about why OTFS might be a candidate to help them solve the challenges of integrated sensing and communication. So that's what Cohere is. We're based in California, relatively small team, big aspiration to try to make the industry better and more profitable as we go from 5G to 6G.
That's great. Thanks, Ray. Mark Kahn from a small mom and pop shop you may have heard of, Lockheed Martin. So Mark, I'm really interested to hear what you have to say about 6G and DoD and why it's important to Lockheed. You know, the kind of the one pet peeve I have is when people talk about 5G and cat videos. I'm like, oh, stop. It's more than just watching a video on your phone. So please take it away. Interested to hear what you have to say.
All right, thank you. Yeah, thanks for having me. My name is Mark Kahn. I'm a senior fellow at that small company called Lockheed Martin. I've been there for about 13 years. Started my career in the defense world, you know, working back in the 1980s, and then took a stint off for about 20 years to work in Silicon Valley in a series of startups, small startups, and the last one was bought by Lockheed, so I ended up back in that industry again. And about 4.5 years ago or so, our CEO, our new CEO was Jim Takelet, came from American Tower, many of you might know, from the telecom business. And he had a vision, and he went on to CNBC one day, not long after he arrived, and announced that Lockheed Martin was developing a 5G.mil system. And at that point, our CTO came to me and said, Mark, go figure out what a 5G.mil system is, and let's see if we can build it. So we put together a Tiger team for a number of weeks. We spent a couple of months going through the 5G standards and how it compares and how it might be utilized in terms of communications for the military applications around the world. We ended up with roughly like 81 or so gaps that we saw, so we began developing in earnest. The company invested right now just about $300 million in research and development, to build the system that we're now deploying with 5G.MIL. And the key things that we did differently with 5G.MIL, which gives a little bit of a vision maybe of where we see 6G helping us out, is clearly the number one gap that we found with commercial in its transition to military applications was in security, the ways that we handle security. So things we do with encryption and things that we do with securing the over-the-air waveforms, like some of the alternative waveforms that you heard Ray mention, those are the kind of things we're absolutely doing now in real time in our operations. So security was one. Another one was interoperability. In the military, many of the systems that have been in use around the world have been so for 50 years. There's an embedded base of these radios and these systems which are not going to disappear. They are not going to be replaced by 5G anytime soon. So the ability for a 5G system to merge with tactical and strategic military communications was critical. And it had to be done in such a way that we can control and monitor them jointly, and then be sure that we can do all the translations and all the business logic that takes place when you move from one system to another. So the goal was that if a session was up on a 5G phone in a benign environment and it suddenly became a contested environment, it could easily slip into a military mode in which we didn't lose the session, we didn't lose the application layer, we maintained connectivity. So that's one aspect of that interoperability, which is a big deal. And then lastly, the other is kind of resilience, which is related to that interoperability. So for resilience, we had to recognize early on that the over-the-air waveform for 5G that goes to the user equipment, there had to be times when that had to be completely replaced. That would not be a safe waveform for many warfighters if you're at the tactical edge, where you're easily detected, easily geolocated, easily targeted. So that was a number one concern for many of the services. So I'll talk a little bit later and certainly be willing to answer questions. There's ways that we do that, much like the 5G phone allows you to transition between Wi-Fi and cellular. Similar things can be done where you can have an alternative radio access technology, or RAT, available for you. So as those kind of things expand with 6G, we're anticipating that that's an area that we're going to want to work in quite extensively. So at present, all of these systems have been built, and our main objective, Lockheed Martin, is really we produce a lot of very large military platforms, so spacecraft, aircraft, ships, terrestrial vehicles, et cetera. And around the world, between our allies and our partners, it's all about connectivity. And a lot of them refer to it as hyperconnectivity, so that those platforms and those warfighters that are associated with those platforms are never disconnected, that they have a graceful degradation down to under the most difficult, challenging conditions. We heard a lot of discussions earlier about shared spectrum and things like that. Well, imagine trying to deliver some quality of service where those in your environment are determined to ensure you cannot communicate, in terms of the enemy and those sorts of things. So what we've learned through this 4.5 years with developing and adapting 5G is that things that were defined in 5G that were in the standards but not necessarily built yet, things like N3IWF and ATSSS, the NTN work that's going on, et cetera, the military needs those now because all the reasons and the challenges that we have. So we need it earlier than the commercial world. And if the commercial world doesn't adopt it, then we have to push it and develop it with our vendor base. So the lesson that we learned over these last couple of years was we are not going to compete with the commercial market. What's going to be built in the industry is going to be built by the commercial market and their investments. And we have to make sure that we are completely compliant. So the open standards comments earlier by the panel earlier today absolutely resonate with us. We attempt to make no changes to 5G, but we do attempt to develop and implement technologies that are defined in 5G, not yet made sort of commercially available. And that's where I think 6G is going to take us to. And we're looking forward to ensuring that all these things that we've sort of done to accelerate certain capabilities for the military, we are now actively influencing in 6G. So thanks.
Thanks, Mark. If you were at Mobile World in Barcelona in 2023, Jim Takelet actually gave a keynote and talk with you, Ray, actually. And it was groundbreaking, the way he discussed comms in the DoD world. It really kind of brings it all together, and that digital does underpin everything else. So it was fascinating. Great, so Millen has a PowerPoint. So I'm going to skip. We'll do Millen after Ian. So Ian, in the CTO's office at Viavi, author. And you're NTIA winner. Congratulations for winning the a grant, and I hear that's getting rolled out soon. So we'd love to hear your thoughts on new features for 6G.
Great, thanks, Deanne. Thanks for having me here. As Deanne mentioned, so my name is Ian Wong. I work in the CTO office for Viavi. For some of you who may not know us, so we are a test and measurement company based in the United States in Chandler, Arizona. We're a $1.2 billion company. We focus a lot on network test and measurement in the lab. So we actually test all the major base station manufacturers' base stations in their labs. We also test operators' networks in the field and also provide software for operators to assure their networks, to optimize their networks. So one thing that folks may not know, we actually also make money out of money. We actually supply the ink that goes in your dollar bills to make sure that they're not counterfeited. And we also actually do 3D sensing. Our filters are actually found in probably all of your smartphones for the basically for AR types of applications, and also intersatellite links. So that's something that a lot of folks don't know. I want to throw that out there.
That's a fun fact.
That's a fun fact. But my day job is actually a lot of ORAN. So I actually co-chair the test integration group in the ORAN Alliance. And very recently, we also won the one of the 3 labs awarded by NTIA, NOFO 1. As you all know, one of them went to a small operator called AT&T, another one to Dish. Oops, do I have to pay $5 now? EcoStar. And then the third one actually is to us, to Viavi. So we're opening that lab in October 7th. So if you received an email, please RSVP to that. If you have not, come reach out to us. We're open to the whole ecosystem to show up. It's a lab in Chandler, Arizona. We called it VALOR. Stands for Viavi Automated Lab as a Service for Open RAN. I take pride in coming up with that acronym. And basically it's meant to really open up the ecosystem for all players to be able to test using Open RAN equipment. That is, our goal is in the period of 3 years to totally drive down the cost of test through automation and through cloud and through AI, right? 3 things that we heard that the US is really focused on. So all the things that was talked about in the first panel on ORAN, we're fully behind that. It's part of our strategy. We actually joined ORAN before it became ORAN, when it was just XRAN form. So we're seeing the fruits of that early strategic investment from our side, because we feel that this is the wave of the future, right? This is how we change networks. This is how also the United States can reassert its dominance in mobile communications. So we heard the 3 things, right? AI, software, that cloud are things that the United States are really poised to lead in. The 4th one that was forgotten to mention is actually test and measurement. We actually have, between us and my friend here, Roger Keysight, are the 2 major test and measurement players in this field, and we're both American companies. So don't forget the 4th one. Okay. With that, I'll pass it back.
Thanks, Ian. Millen, Vice President and Head of the Wireless Lab at Interdigital. We're excited to hear your presentation, so please take the floor.
Okay, thank you very much. Pleasure to be here. Good morning, if it's still morning. A couple of years ago, I made a keynote presentation at 6G Symposium, and at that time, 6G was a blurred vision, if I could say. Now, fast forward 2 years later, it's starting to take some shape. We still have some unknowns, which we're all talking about here. There are many we haven't talked about. So after I give you a quick introduction about myself and the company, I thought I could use a few slides and just ground the discussion a little bit. We talked a lot about multiple things. So really, even though nobody, not many people use slides during this forum. Thank you, Alex, for letting me use the slides. So you guys talked about small company jokingly. I actually do work for a very small company. I joined InterDigital about 2.5 years ago. Feels like a long timer now. But prior to that, I spent 25 years as a combination of Motorola and Nokia, building terrestrial systems, Iridium systems, as I mentioned earlier. And prior to that, I had a pleasure of working in the aerospace and defense industry. I worked a lot with Martin Marietta at that time, took a lot of trips to Denver. So as we talk about military applications and talk about terrestrial applications, talk about NTN, I get it. I actually do get it. And I understand the challenges. One thing that all these years have taught me is it's very easy to get excited about a lot of things. But then as you start to work through it, you start to realize that there are reasons why the things have evolved that they have, and there are things that, the problems that have not been solved. But as I look forward to 6G, I look forward to all the features and the tools that are being made available for us. I get really excited about it. And I jokingly tell my guys, I feel like a kid in a candy store, but I can have only so many candies. That's my frustration. So with that said, let me tell you a little bit about InterDigital. For those who don't know, and those who were not here yesterday, Rajesh, our CTO, was on a panel yesterday. He briefly touched on what we do. So we are over a 50-year-old company, and over 5 decades, wireless and video research and innovation has been the key theme of our company. We have one of the strongest technology portfolio in wireless, video, and AI. And then we have used these technologies and the IP that we have created to license them to bigger companies like the Apples and the Samsungs and so forth. And it's because of our technology, there's more than 6 billion devices that are connected with each other. So just think about that. Anytime you pick up a smartphone, it has our technology. Anytime you think about the technologies used that are developed in 3GPP, that has our technologies. So it has a very, very far reach. So we have 3 different labs where we do all the research in. Wireless lab, which I have a pleasure of leading. We have some really superstars and I would say Einsteins of the world who have been developing innovative technologies to make the consumer experiences much better over the years, back from 3G, 4G, 5G, and now focused on 6G. Our video labs, they do research so that the video images can be more pleasing, they could be more crisper, they could be more immersive. And our AI lab primarily is looking at all the fundamental research that we could use to enhance our wireless applications or video applications and so on and so forth. So with that, let me migrate into the 6G world. I'm sure if you have not maybe seen once, but many, many times, the diagram that I show here on the left-hand side, it comes from IMT 2030 vision document. And it tells you what are the usage scenarios that we should think about when it comes to 6G. It's built on 3 areas, the triangle that's in the center of the 5G areas, and those areas will continue to evolve. So when we talk about 6G, don't forget that 5G will have a major role to play in 6G. A lot of features will carry over. A lot of work that's being done in 5G today or 5G advanced today will carry over. And EMBB, which is enhanced mobile broadband, will become more like immersive communications, massive machine type communications. We'll continue to add more and more capability to it. And what some people used to call URLLC, the ultra reliable low latency, will also continue to evolve towards hyper reliable communications. So what are the new trends in 6G? We talked a lot about integrated sensing and communications. We talked a lot about integrated AI and communications, ubiquitous connectivity. Now, one might say, why is ubiquitous connectivity a new trend in 6G? My personal opinion, we've been trying to connect the unconnected and have ubiquitous coverage since almost day one. As I mentioned earlier, Iridium was one of those satellite constellations which kind of started down the path of connecting the unconnected, and that was in the mid-90s. Some people may recognize this slide also, which is a reuse from a 3GPP workshop that was held in Rotterdam in May of this year. And as you can see, GSMA and GMN and the market partners and the voice of the SDOs, what are they saying as the potential drivers for 6G? Security, everybody wants security. Right? We all talked a lot about security. Now, security can take multiple different forms. You can build in security at the physical layer. You can build in security at the top layer. You can build in the trust between applications. You can build in trust in the networks. So it cuts through a lot of different layers, but as you can see, that's a big driver for 6G. Then you look at AI. Everybody wants AI. I'm going to talk a little bit more about AI and how it could be used. You can see sensing. Everybody wants sensing. Everybody wants immersive communications. So it starts to give you a clue when we talk about commercialization, monetization, what are the market drivers? So it's something we got to look at. So integrated sensing and communication. So what does it really mean? So using radio signals to sense or detect and identify objects and surfaces within an environment. And that is a new capability. We always had sensing and communications as two different networks. Now we have ability to combine them too. And what does it do? It gives you the capability of sensing spatial information about unconnected objects that are not part of your 3GPP objects and your connected devices to your network and their movements in the surroundings. And from that, you can support lots of use cases, which we'll talk about in a few minutes anyhow.
So Milind, if I could stop you right there, because I think that's an excellent opportunity to expand on integrated sensing. It's going to be such an important part of 6G. So maybe I could ask Ray a quick question, and then we can get back to your presentation. So Ray, what do you see are the primary challenges and opportunities to ISAC in its current research with 6G waveforms?
Yeah, so if I think of integrated sensing and communication, I do differentiate it from the term joint sensing communication. Not everybody does. So when you do two things together, you can do them like ISDN, where you put some data and some voice together with the outcome of ISDN. Or you can do it like IP did, where you put data and voice and you create a common control plane. So we start with the notion of integrated as opposed to joint. Generally speaking, and not for those that are purists in the room, I might offend you by being general, but I'm trying to keep this fairly simple, in my own head at least. You generally use pulse-based technologies, or TDM, for sensing and ranging and military radars and commercial radars, generally. And the world often uses tone-based technologies for communication architectures. And as a result, most of my career, I thought there were only two options, TDM or FDM. Now, of course, there's CDMA, which is another kettle of fish, but it turns out that if you look through the delay Doppler lens, which is why we chose this representation theory that we chose, you end up creating what we call a pulsone. right, which actually is both a pulse and a tone at the same time. And that's the simplest way I can explain that we do integrated sensing and communication in that waveform. We can get into all of the details behind that are on our website if you want to go down that road. But if you look at time division or frequency division, you're going to get sensing networks and you're going to get communication networks, and you're going to try to integrate them to the extent that you can. But you really have to go all in and move into a domain that senses and communicates in the same resource, literally the same subframe. And it is possible, despite the fact that people have been struggling with it for decades and chasing this. And I think if we open that up, it doesn't just address the corner case of the strenuous warfighter environment that's been trying to do that for a whole bunch of really important reasons, which are probably more technical than I understand even, Mark, right? But you open the cellular environment to localization down to the level that you can really monetize. And now, that's when you broaden it from a niche application, which is extremely important, and there are other niche applications like MTNs that probably can use joint sensing and communication as well, to a broad-based approach. Now, it's different, and as a result, it generates resistance, but I've lived in a world of promoting different things before, and if you don't die, it's a great outcome, right? So if you think of what CDMA started, people argued about CDMA and they argued about Erlangs and Erlangs, but it was never about that to me. It was about a soft handoff. And if you think about the way the world started, it was $1 a minute and 10-mile radius cell sites. You know how many times you handed off? 0. The average holding time was a minute, and the range of a base station was always longer than that. Then you come down to 30 cents a minute and 2-mile base stations, and you start handing off, and you expose the problem of a flawed handoff architecture that, for a bunch of whole reasons that it's not worth getting into, and someone invents soft handoff, and it creates an industry change, but of course years of resistance to that, but then the world gets used to it, and it becomes a religious norm, and everybody says, don't change from that. And then you end up trying to mobilize the internet, and the world says, well, let's make the internet conform to us. At Flarion, we thought, well, that's kind of silly. The internet's pretty big, and there's probably not going to be a digital twin of the internet in mobile, right? So why don't we allow the internet to move? And if you remember, Tom this morning said, you know, I think of LTE as just a Ethernet plug. Ha, he got it, right? It only took 20 years for us to realize that it was possible to move the internet, the Ethernet wire, right? So what we're saying is, there's now a joint sensing and integrated sensing and communication capability if you merge TDMA and FDMA into a pulse zone. It exists. We've already built it. It's already protected with a ton of intellectual property, so we're happy to explain it. And it does drive warfighter capabilities. It'll also deliver to the industry. And all we really ask 3GPP to do is allow it to be one of multiple outcomes in 6G, because 6G should be a multi-protocol platform that supports software-defined radios so that we can get out of this 10-year debacle we're in and just allow for continuous innovation at the radio layer on top of an architecture. So that's how I think of, I hope that was not too long an answer, to integrated sensing and communication. But when I explain it that way, what I'm trying to say is you have to know why it is you're proposing change, because you're going to get resistance when you propose change. But if you can explain what the goal is, sometimes you can get people to join you, right? And then you have to demonstrate it, and then they have to see it, and then a coalition builds, and a support builds, and then the world moves, right? And we're in that process right now of trying to explain, why would you go through the problem of going into the delayed Doppler mode? Well, what happens is you literally expose the geometry of all the reflections that are creating this equalized channel at the receiver. You see it geometrically. You see the dominant reflections that are creating the energy. You're sensing. You're already doing it. That's what our USM does. And that's why it can, once you see that, think about like in the US Capitol, when you give a tour in the US Capitol, and some of us have probably done this, we're not that far from it, by the way. You stand there, Mark, I'll stand over here, we whisper, we hear each other, and there's like 1,000 people around. And it's like, how did you do that? Well, the geometry of the room happens to reflect our energy. Well, it doesn't reflect English or Greek or Latin or German. It reflects energy, right? We decide how to encode our information in the language we choose. So when we created this geometric mapping capability, It works on Wi-Fi, 4G, 5G, 6G, military, proprietary waveforms, anything. So think of it as a universal platform that will host multiple Gs. And I think that's where 6G needs to go. So back to you.
Great, it's a great example.
I have a couple of thoughts on it.
You do, it's great. Millen, if you don't mind, I'd love to stay on this. It's incredibly technical, so I think, especially for people like me, policy people, it's good to kind of stay on topic, and then we can move on. So Mark, I would love to bring you in on this conversation. I mean, the applications for defense and aerospace are immense. How is Lockheed looking at ISAC as it relates to 6G?
Yeah, I would say I'd certainly build on what Ray said, that wherever 6G goes with their ability to inherently integrate sensing with the communications, we would absolutely take advantage of that. We too, as you might expect in a warfighting environment, having situational awareness of everything around you, not just to improve your communications capability, right, but there's an underlying mission that you're trying to accomplish. So part of sensing could also reveal things like where somebody is in the environment that you simply don't want to direct any energy to. You don't want that individual or that platform to even know you're there or communicating. So there's an awareness that comes with understanding your environment. Now, I'd have to defer to our aerospace team in Lockheed Martin when I say things like, we make the F-35 fighter aircraft. It's a very exquisite sensor that does very exquisite sensing of the environment, as you noted, Ray, like with radar systems, et cetera, that are being used, many different modalities. So we would certainly seek to mesh everything that we do on existing military platforms in which they do sense their environment, they do have situational awareness, they do have an understanding of the status and health of their communication network. We would combine all of those. And I would say that the work that's going to go on with integrated sensing and communications coupled with all the additional sensing that's available on the platforms, which would be co-located with either user equipment or base station equipment in these types of environments, or at least part of the data network that combines all of those in a particular battle space, that will absolutely be used to adapt and orchestrate and manage the overall communication system. And that could be everything from where you place your platforms, new routes, to avoid interferers or jammers or threats that are in a given environment, to changing your spectrum, to changing your waveform, et cetera. And lastly, I sort of would build on top of that, there's initiatives now within the services, sort of around the world in terms of military, where they're going one step beyond integrated sensing and communications, and it's integrated sensing, communications, and then the mission processing itself. So the radars themselves could also become part of that integrated RF front end. So from my perspective, like many things we've heard, there's been visions of these things for decades. And we're really on the cusp of once wideband software-defined radios really become something that's practical and it can be useful, and we can cover huge swaths of spectrum, huge swaths of power, together, then an integrated sensing, comms, and perhaps even mission can all take place on single apertures for these types of platforms and systems. And that's really where the military systems want to go ultimately. They want a converged processor for that front end. And I think the promise of 5G and 6G, in which the comms, the edge processing, the AI that's used for things like target recognition or all the things that are listed as the types of things you want to adapt and adjust in a comm system, that's all going to come into play. And we are absolutely committed to positioning our architecture for our 5G.MIL systems to host and become a framework that can support that. So again, I resonate with the idea that if these are all kept open and we do this in an intelligent way, specific applications which are niche for the DoD and things we need and the way we need to use it, we can absolutely use this technology. But you have to make sure it stays open enough so that we can actually exploit that.
That's great, thanks Mark. So Ian, let's talk about testing hurdles. So I actually have a two-part. How do you feel that we are positioned as an industry to move forward testing with ISAC? And I feel from my own personal experience, I was in Congress and the roll-up to 4G, it was at NTIA, the roll-up to 5G. I feel like we're in a better posture this time around. We're talking about it much sooner. Does that give us and you, Viavi, an advantage as we start looking and talking about these technologies today?
Yeah, I mean, absolutely. I think, obviously, we've been doing, as an industry, communication for decades, right, since 1G. And I think adding sensing as a new modality to this fast network that we have is not, it's not treated lightly, right? I mean, it's a brand new, potentially disruptive service that MNOs or private networks can offer. So for us as a test and measurement company, we're usually pulled in earliest in any of these technological shifts. So we're looking into, I mean, again, like, because decades of experience on communications allowed us to focus on modeling, let's say, the channel, right? It's all about wireless, right? It's all about channel. As you know, there's actually two ways to model the channel as the industry does it. It's called deterministic, which means it's about rays. Think about shooting a laser and then seeing how those rays come to a user. But also stochastic, more statistical, right? And really, over the decades, we've perfected the modeling of the channel for communications, both using deterministic and stochastic methods. But they're really geared for, again, just improving the quality of service of communication to a user. Now that you add sensing to it, all of a sudden, things happening around the user becomes much more critical, right? You're sensing objects that are not really, around the UE, around the base station. So that means new channel models needs to be generated. And with new models means new ways to emulate these channels, and that's something that we're doing today. So we're investing a lot on digital twins of an environment, right? Previously, when you can rely on stochastic models, you can do generic receivers that can work in a lot of different environments. If you're doing sensing, now you have to deal with let's call it the modeling of the environment, the modeling of the surfaces, how that reflects the rays, and how that allows whether it's the UE or the base station to again sense its environment. So as far as like things that we're doing today, is because we test base stations, right? That's one of our parts of our portfolio, one of the bigger parts of our business. And now these base stations need to, we need to emulate not just the UEs, but also the environment as seen by the base station, so that the algorithms required on both the U and the base station can be developed to actually perform the sensing that is expected that will add the value, right? Again, there's a lot of modalities to do sensing. There's LiDAR, there's radar. But now if you integrate that in this network of ours in the mobile communications, what are the really key use cases, right? Where can it really add value? I think there's a lot of debate out there on where those can be, intrusion detection, public safety, the military, and all that. And those are things that our customers today are grappling with, and our emulation platforms are helping with that already.
Yeah, I think it's so important to focus on use cases too. So if anyone else has comments on
So Ian, I just want to respond to something you said, and this may sound subtle, but some folks in the room probably live in this world. We have been building channel models at least as long as I've been in the wireless industry, since '86. And it's getting more and more complex, and as the model becomes doubly spread into both delay and Doppler, we're running up against cyclic prefixes and challenges, et cetera, et cetera. You can use a sensing network, or you can go to a waveform that operates model free. Sort of makes your head hurt. Like, what if the real answer is stop building channel models? Because if the waveform it does sensing, it is the channel model. Because the channel is a series of reflectors that you talked about, like figuring it out. So what if the waveform itself operates model free and feeds into an AI engine, and it's all different, right? So that's where Cohere's coming from. Now, it's a crazy idea, but I'll just say to you, there was a time, some folks in the room are old enough, to where you had a Rand McNally map, and then you thanked Yahoo for giving you an online map. And some folks are in the room are probably going like, what the hell are you talking about? Like, it wasn't Google Maps back then? But think about a company that was so committed to the mapping of the physical universe that it eliminated Garmin from that space, and all of the other companies that should have had the right to own that space, but just weren't committed enough to move it into real time, to integrate it with real-time traffic, and to put it on your phone. And no one can catch them because they're all in on it. So what we're going to propose, just to be transparent, is we're going to propose going all in on an integrated sensing and communication waveform as at least one of the options, and let it play out so that the world can move to a model-free environment, as the rest of the world is also looking at continuing to drive the model. Because some of the things that are showing up in power and compute are driven by more and more and more and more complex modeling, and it might be possible to operate model-free and tame the power and compute. Thoughts on that? Crazy?
Yeah, a little crazy, because I guess I
We like crazy.
still electrical engineer at heart, and the physics don't change.
But it's not physics, it's
yeah,
geometry.
it's,
If you're living in the geometry world, and for those of you that went through high school, geometry is a lot easier than physics. And so what happens is the physicists get seduced by but think about what you said. As an electrical engineer, I'm going to stay in physics. I'm like, well, what if we move the world to geometry and realize that, in fact, the channel is just a series of up to 15 dominant reflections? And by the way, they don't move very fast, or they don't move at all. So as a result, you get a completely different look. That's what we're proposing.
Yeah, I'll add a couple more thoughts to this conversation as
Go ahead.
well. You bring up some good points, no doubt about that. And one of the, I'm going to draw an analogy that I was involved with, and let's use Iridium as an example. It was ahead of its time. What happened to the company? It went bankrupt because there was lots of issues with using and adapting that technology at the time. Now, when I compare that to what's happening today, OFDM is sort of a gold standard now because it's been used in 4G, it's been used in 5G, and like you said, it's a resistance, perhaps, it's perhaps understanding, perhaps whatever you call it, but when roughly 2,000 people who represent all the companies around the world come to 3GPP meetings, and majority of them, I think Wanshi's here somewhere today, he can talk to it more than I can, but roughly 500-600 people that come together and start looking at the waveforms, start looking at the channel models. They're looking at the ISAC channel model today. There has to be a really, really compelling reason why they should deviate from the gold standard, right? And where is that advantage coming from? Is the advantage coming from performance improvement? Is the advantage coming from cost improvement? And what happens with all the embedded legacy systems, et cetera, right? So, your question was about use case. I want to get to that a little bit. But I also wanted to comment on waveform because we're doing some research as well within InterDigital, and we looked at OTFS, we looked at OFDMs, we looked at adding chirp on top of OFDM. So we're looking at all the different things, but we all kind of come down to that one question about what is the compelling argument that we can take to all these delegates and convince them. That's the hardest part.
So can I play devil's advocate for you on that point? You said,
Absolutely.
why would we move away from the gold standard? Let's use BlackBerry as an example. They were the gold standard of cellular smartphones, and now they're not even in the business anymore. They have like a side cybersecurity business that they've set up. Shouldn't we always be looking to the next best thing?
Absolutely, absolutely. I think there is a method in how the systems move, especially when it comes to standardization of it. And as long as I think you have the mechanisms and methods to get through the system, I think the good ideas will always win. Because at the end of the day, it's a consensus-based specification that gets developed with the solutions that have the best merits. And I'm not saying that, which is exactly what we were trying to do with Iridium. It was non-standard based. It was really a novel idea for the time. But other things didn't work out. So I'm not saying we should ignore it. We absolutely should, explore those ideas. But then there is a method in which how you standardize it.
Well, you probably realize that, first of all, I appreciate the gold standard reference to OFDM, having been the founder of Flareon. There was There was a time where CDMA was the gold standard,
Yeah.
and we came to 3GPP, and people said, we already have a gold standard. Why would you propose OFDM? So, like, I just think this question answers itself. Like, it's amazing to me that every generation resists, adopts, and gets stuck. Now we don't want to change this. Oh my God, I wish someone had said in 2002, OFDM is the gold standard. But they didn't. They said, we already have CDMA. We have a gold standard. Go away. So I have no problem with people telling us to go away. We already have a gold standard. We're just going to persist through that. As to what the critical use case is, I do think if you stay stuck in the physics problem that is escalating into a power and compute problem, and oh, by the way, it gives you an answer that's good for about 50 microseconds, which means you're stuck in an architecture of highly distributed edge as opposed to the centralized potential of Cloud RAN, you're missing the point. It's an architectural issue. People want to know what's the use case. We already have things go. Everyone has all the bandwidth they need. It's faster than Netflix can deliver the movie, I think somebody said earlier yesterday. But it's an architectural issue. And then you also have to ask yourself, if OFDM is the gold standard and everything's working so well, why does the entire supply chain have the market cap that it has right now? Why does the entire operator community have the market cap that they have right now? The industry's struggling.
Yeah.
Despite the gold standard, the industry's struggling, and it needs some creative thinking, and we're just going to try to push through some of that, and hopefully
I
people
think
might be open.
you will get, just maybe one more point, Diane, if you allow me. You know, integrated sensing and communication touches all the layers of the network, right? I think what we're talking about is certainly waveform is one of those layers that has to be thought through in terms of what is the best strategy for that. But then as you go up in the layers, whether it's within RAN layers or the core network layers or applications and services, sensing is going to play a major part because it'll create services, and regardless of what waveform we use, it's going to create services, and it's going to allow new businesses to come up with some creative ideas. So I think in terms of the use cases, there's a lot more flexibility and a lot more breadth that integrated sensing and communications will bring.
If I may just add, like on the use case side, right? Like we should learn from, I mean, we heard it yesterday with 5G, like there's all these verticals and we're gonna supply them with all these great, 5G is the best thing that can happen to you and it'll solve all your problems. We're kind of falling to the same track with sensing. We're saying sensing, like the whole network, why not? I think we should engage with the vertical community and understand where are the main use cases, right? Like, is it public safety? Is it intrusion detection? Is it, you know, stadiums? Is it commercial? Is it military? I think understanding those use cases will inform us as a technological community to provide the right technological solution. And I think if we get too much into the weeds of this technology versus that technology without understanding the use case, I think it's a trap that we should avoid. Yeah.
You know, and it's an interesting thought, right? What came first, you know, the chicken or the egg? You know, 4G brought the app economy. So, you know, does the business use case side drive 6G, or is what we're able to build going to drive the use case business side? So for Alex, for next year, if you're so kind to invite me back, I say we do bingo cards for the audience. We've heard physics, geometry, BlackBerry. It's been a great conversation, new things popping up. Mark, if I can take it back over to you to talk about 6G, Lockheed, and kind of stick with the line of use cases. You know, obviously we can't talk about classified things, and I'm sure that's where all the real exciting stuff is happening. But from an unclassified standpoint, what gets you excited about 6G, and how is that going to not only help improve the posture of defense, aerospace, but just the warfighter? How do we keep, you know, the men and women in the F-35 safe?
Right, right. Well, I think, and I'm glad you ended with that, because that's kind of that's where it ought to really start, right? Whoever, the end warfighter, you know, what we recognized about 4 or 5 years ago, right? When a service man or woman goes off to duty, and they're driving to the airport with their kid, and their kid's streaming Netflix, and then the serviceman gets out, and they give them a radio that was built 50 years ago, and they can get, you know, 1,200 baud, you know, sometimes under certain conditions. That's not a great way to maintain safety, you know, of our forces and our platform. So that's obviously the killer app no pun intended, is that it's all about safety for those platforms and the service.
Just don't talk about pagers, please.
That's right.
Too soon.
So back to use cases then. We kind of see it rolling out in a couple of ways, and we kind of see it, what we're hearing from the services and what we're hearing from our allies and partners around the world. Initial deployments for 5G are happening at the bases. So the large bases are being deployed really just to get the personnel connected, and modernize the bases. And a lot of that activity is going on now. And at those facilities, there's also quite a bit of work that's going on then as you go out to say if they're developing aircraft there, or if they have a flight line, for instance, then how you instrument and manage flight line and some of those types of things becomes a natural extension. And because some of these platforms utilize waveforms and technologies which are not 5G, so that interoperability of a 5G system and a native platform is a use case for us. And on the flight line side, we're doing quite a bit of work with the folks that are doing sustainment, flight line logistics, and they really want to have maintenance capabilities that, as Ray will know, like with an aircraft, the amount of time that aircraft spends on its wheels is lost time. You want to get that aircraft back in the air. So it's got to be a quick turnaround on maintenance. So what they are doing now is a lot of the training that's going on with these folks is allowing them to do maintenance and logistics in real time. As aircraft are coming in or platforms are coming in, they're already transmitting all their telemetry data, all the information about the health and status of the system. That's already being used to order parts, move things within the flight line, and then the maintainers can go out and they can be using mixed reality then, right, to look at an aircraft. You can have somebody that's fairly junior now enlisted and come out and can make a rather sophisticated change in maintenance through the adaptation of mixed reality. And we're also doing demonstrations now where we're utilizing, because it's sometimes so difficult to do surveys of a platform, a large platform that's come in for maintenance, that drones are being used and autonomous vehicles are being used to do inspection of the health and status of systems, and that's all being merged at the tactical edge. And that that edge there with the flight line is a place too where maybe that has to take place in a classified type of system. So the edge processing might include multiple enclaves of security, and it might also include reach back into multiple secure networks to allow that. So we think that's sort of a very next natural step in use cases. The next one that we're doing a lot of work with right now is also in training and exercises. We just did a demo last week that we were able to show where we outfitted we had ground troops, like special ops forces type, wandering out on a tarmac. They had rifles, and they had them instrumented with 5G so they could maintain attitude and understand where it's pointed and what's the status of that weapon, so that when somebody pulls a trigger, instead of doing laser tag anymore, which can be impacted by foliage and other things that cause it to not be very accurate, all that is done is we're sending very short messages back. We're processing that directly at the edge, low latency, and they make a determination of what the projectile arc would have been, whether it's a hit or a miss, those kind of things. So really fascinating, and it is making measurements too of all the local environment. We have all of the LiDAR that's been done for the local environment. So that's a fantastic way for us to train and have exercises in which a lot more of it's being done with the help of the communication system and the edge processing and the AI that goes with it. And then let me just say that sort of as we go a little bit further and out to the tactical edge, the applications that are going to become more and more important to us are certainly the interoperability of those systems, like I said, but the embedding then of the AI and such that on the military side, it's all about, as I mentioned earlier, having shared situational awareness and a common operating picture. So the application that's really most critical as we go out into the field then at the tactical edge is going to be, how do I move that common operating picture around a heterogeneous, dynamic, challenged network very quickly? And a lot of the services, we've done some work with the Marine Corps at Camp Pendleton. There's work that's coming up now with the Army. There's this whole notion of what used to be the way you went out and set up tents and rolled out cables and did things for a forward operating base or for a command post. That's all got to go wireless. And the idea is that any command post that's up for more than a few hours or a few days is no longer safe. So therefore, you can bring vehicles and drones, et cetera, out and instrument and create what would be a 5G or a 6G bubble that serves all of the warfighters within that bubble. That bubble can then collapse, move, and set up again in another location. And that's really where we're seeing a lot of the early pull. The last thing I'll say is that we too are engaged in NTN work, and there is a strong demand for that sort of last resort signal, that as a warfighter or a platform might lose more and more capability due to results of the battle or results of being in a contested RF space, the ability to get at least any message back, through a space link or through even an untrusted, network, like a commercial network, that's absolutely being considered so that you're never left without the ability to make contact.
Well, I appreciate you bringing up NTN. When you talk about 6G, you often hear ISAC, and then next you hear NTN. So maybe a jump ball for all of you. If you'd like to, I'm still pulling the basketball. I'm sorry. How do you see NTN being integrated? Is it 6G? Can we do it with 5G? What's needed to do the integration? I mean, you're hearing companies kind of move in this direction, but are we there completely? Is there testing available? So I'm happy for anyone to take and run.
Maybe I could start with where we are in 5G today. I mean, clearly we heard quite a bit on NTN previous panel, and that's something that a lot of the satellite companies now we are using our gear to test them as real base stations. I mean, again, like our business has always been testing base stations, and they now need to make sure they have quality of service. How many UEs can I serve in a particular geographical area? How do I deal with latency? I mean, now we have to, again, going back to channel modeling, Ray, you kind of need to understand the satellite channel. It's like, how does especially in the LEO environment with those Dopplers, how do we compensate for all of that? I mean, the standards are there, release 17, but there's always room to get better. I mean, NTN was added, let's say, somewhere in the middle. So it wasn't really designed. Again, it's terrestrial first, NTN later. There's an opportunity to bake that into 6G at the get-go. Can our protocol be better to have an integrated TN-NTN network? Can it be lighter? Can it be much more, again, like if you look at the difference between 4G and 5G, it's in the flexibility of the waveform, right? You add a lot of parameters so you can cover lots of use cases. I think now we've expanded that parameter space to include sky, air, plus sensing. So think about that, from a 3GPP standpoint, when we start standardizing the next wave, now we have to come up with a solution that needs to serve both going up in space and also expanding the modality to sensing. So it's a challenge. It's a fun challenge for any engineer out there. But I think Ray's company thinks he has a solution. There might be others, but that's the fun part about the new generation. It invigorates us, innovators and thinkers, to think about, okay, again, may the best man, best technology win, best woman, technology win, and then let's see. I think to me that's exciting and invigorating.
So from our perspective, clearly, needless to say, integration of terrestrial and non-terrestrial networks is a way to provide that ubiquitous connectivity. We've been working at it for a very long time. And as we discussed in the previous forum, you could refer to NTN as UAVs, you could refer to them as the high altitude platforms, which are about at 60,000 feet level. Then you could talk about low Earth orbit satellite, you could talk about mid-Earth satellite, you could talk about GEO, right? It's a whole network of networks, if you can say it that way. I think it always comes down to a few basics, though, in my mind. So first of all, the laws of physics, very, very important in terms of the connectivity, in terms of the Doppler effects, in terms of the footprint of a cell, how the cells will interfere with each other, how do you do the handoffs, and especially when you are providing a coverage around smaller countries and you bleed into the other country, then which spectrum do you use? So there's a host of things that have to be addressed. But I'm encouraged to see a very active participation from NTN community in the 3GPP standardization forums. And you know, we talked a lot about the Gs being 10-year-long cycles and so forth. But you know, for those of us who are familiar with standards development process, the standards team release a specification every 18 months or so. And so there is an opportunity to take those specifications and use those to make the modifications, whether it's in the hardware space, whether it's in the software space, and so on and so forth. And I think, if I'm not mistaken, NTN is probably on the 4th or the 5th release where they've been working together to develop these specifications. So I think it'll continue to evolve. Some of the capabilities there today, but you know, we're not there yet.
I can make, yeah, just a quick comment about where we are on that. We have invested over the last 3.5 years or so, and we do have an NTN payload now that's built for a fully regenerative NTN capability in LEO, and we're working with the Space Development Agency, which is putting up its own constellation. There's a series of tranches of putting up these LEO satellites. So Lockheed has invested. We've built our own satellite, a copy for ourselves, and we're launching that in December. So we'll have an NTN regenerative capability in space in December, and then we have an experimental network that's set up that we have capabilities in Florida and a couple of different locations around the world where we can then test. And we're very interested in some of the topics that you just mentioned in terms of, I'm keenly interested in the interoperation of an NTN system and a terrestrial network together. You know, and how do we operate? How do we do the handovers, et cetera? So I think the technology exists. We've worked with the usual industry partners on how do we adapt, you know, and look, because we're working with the standards body. So we're gambling, you know, we're working ahead of the standards a little bit, but we figured we needed to do that because we view the space layer as absolutely critical on a military application. And it's critical, too, that it be able to operate because space is also a target, you know, in warfare. So it could be a disconnected satellite that's only one. So when you only have one satellite, it's only got one footprint, you want to make sure everybody in that footprint can talk. So we're trying to solve probably a harder problem, so, you know, certainly than the commercial world. But I think the technology's there, and we've demonstrated, you know, in the synthetic environments and in all the simulations that you can sustain, you know, video. This is an NR, you know, system that's running. You can sustain 5 megabits or so, like in most scenarios when you're operating over a pretty wide swath of coverage. So it's definitely promising. It's more than the short messaging. It's not everything you would get in a terrestrial system, but it's certainly, you know, something that the warfighter is going to appreciate when it comes time.
Great, thank you. So we have about 25 minutes left. I just want to touch on one more point and then open it up for audience questions. I know standards has been mentioned several times in this conversation. I know ADIS is a sponsor of this event and is doing great work on their end. You know, all the good work that you're doing, whether it's testing, R&D, is for naught if we can't bring it to the standards bodies. And it does give you an advantage to have the R&D. What's needed? What are we missing? You hear government policymakers often ask, you know, is it getting to standards bodies? You know, what can they do? What are you seeing on the ground, and how can we put companies in a better position to go to these events around the world and to excel and to get their technology adopted? I'm happy. Would you like to take? Yeah, I'm happy for anyone to take.
Well,
it's kind of off topic a little bit.
Yeah, well, getting people to attend is one thing. Getting them to open their minds beyond the status quo is another. So we're working mostly on the latter part, trying to do demonstrations of what we're doing so that people can see the benefit of changing a perspective. We are working with ADIS, we're working with 3GPP, we're working with all of the standards bodies. But my experience from Flarion was we tried it at 3GPP, no one wanted to change because they had a gold standard. We went to IEEE, they embraced us initially, and then all the 3GPP people came over to IEEE and said we don't want that to happen. So you get what you get out of a standards process. If the world's open to change, then it'll all work out fine.
Sounds like education's a big part of it.
Yeah, education's a big part of it. That's why forums like this, I try to put our position out there, not, I hope not to be immodest or arrogant in a way, but just to say, like, look, we were part of creating what's now perceived to be a gold standard, but we took so much crap along the way from the folks that were part of the prior gold standard. So like, it is what it is. When I heard, if I play back the discussion on sensing and communication, or NTNs, you really have to understand a channel because you've got Doppler issues and you've got delay issues, or you use the term latency, but I think delay, right? Well, what we're proposing is to move the waveform into the delayed Doppler domain. It's done by inverse FFTs, from time to delta time, from frequency to delta frequency. When you're in the delayed Doppler domain, you literally read off the delay in the Doppler. You solve the challenges that you just said are in the way. So if you think about it that way, you've answered your own question. That's why you go to a new paradigm. But it's going to take some time. Those challenges get an order of magnitude harder when you start talking to multiple satellites, which no one thinks is possible because, well, you got a big enough problem with just talking to one that's moving fast. If you start talking to two and network them, that's going to be a problem. Not if you live in a delayed Doppler. If you live in a delayed Doppler domain, everything becomes geometry. You see it. So, but we're going to need some time to, A, do some use cases in partnership with some satellite companies, which we're doing. B, bring our USM to market to make 4G and 5G better, which we're doing. And then C, bring OTFS as a waveform into 3GPP and make our case. And we're doing those things too. And it's going to take some time. It's probably going to take years. But I think it's worth it. And at the end of the day, what we may have is a new gold standard that not only addresses delay in Doppler, but opens up the world of AI, because you end up opening up the fundamental reflectivity of this environment, and it's a deterministic reflective environment. So that's the exciting part. How the standards bodies handle that, I don't know that it's as much visa related as people talk about. I don't know that it's as much attendance related as people talk about. I think it's about whether people can align their interests. That's why we're trying to build a coalition, talk about what we're doing, partner with people, help them win. We're integrating with existing RAN players to make their base stations better at fair economic terms so that carriers can get better spectral efficiency with a software upgrade across an open interface. And we're just hoping to survive the process, you know?
So Ian, if education is so incredibly important, then validation is crucial, correct?
Yeah, absolutely. I mean, I think, speaking a bit about standards, I've kind of been working on, I guess since, I would say, release 8, on LTE. And I mean, the reality is it is stacked against the small players. I mean, that's the reality. If you believe in the technocracy wherein the best idea wins, then there's a chance. And again, forming coalitions is the best way to go about it. But there are also things that I think we need to talk about in terms of how we can improve the process, right? Again, there's this general notion that this 10-year cycle, right? Like we heard about it yesterday. It's like, why does it need to be 10 years? Right? And then say, oh no, but there's actually intermediate releases every 18 months, but those releases kind of tend to be anchored to whatever was determined in the first version. So, and that's basically what we're seeing with 5G and same thing with LTE. So I think there are things that are changing for 6G that, you mentioned education. Viavi, we're actually in the board of the Open Software OAI Software Alliance, Open Air Interface. We support a lot of open source initiatives because we think that the model of, if you look at it in the IT world, right, open source is another way of doing a de facto standard because multiple companies come together, create an API, create the software behind it, and eventually you see things like Kubernetes, Linux kind of take hold and becomes a de facto standard. I think with the softwareization of mobile networks, with the embrace of cloud and AI, there is a school of thought that is, hey, maybe after this or the next generation, we could evolve into a much more softwareized version wherein, let's call it the foundational layer is kept fairly constant because we've understood it really well, but then evolutions can happen in a lot more quicker pace. I think, like standards organizations like the ORAN Alliance is trying to embrace that, wherein the open software is a key part of the standardization process and they feed off of each other. I think initiatives like OAI and SRS on this openness, open source version of the CUDU, which we heard Tom talk about. I think those are all movements in a direction which allows us to innovate quicker. And I think that's something that will be welcome. And in fact, it will also be much more interesting to young people to actually be part of the field, right? I mean, I have a 17-year-old, and he's not really interested in doing what dad does anymore, right? It's not cool anymore. But I think once we kind of get back that innovative spirit, things moving faster, in a software manner, I think that also can help bring in new blood into our industry and again foster the next innovation and come up with the next Cohere, maybe, right? Yeah.
Sounds great.
Coming back to the point of what the governments can do, so I'm in a position where I can see how the innovation is fostered in the European community by the HC and some of the European Commission funding. And when I look at how it's done in the United States, I kind of admire how it's done in Europe. They have billions of dollars invested in research organizations. They allow a group of companies to make a proposal, and those group of companies then work together to advance a research topic related to 5G or 6G and so forth. And I think we had somebody from 6GIA on the forum to talk about that a little bit too. And in contrast, what I see happening in the US is the discussions I have had with some of the funding organizations. First of all, you're required to put in equal amount or more amount of your own funding, which kind of negates the purpose of allowing small companies to make the innovations or do the innovations with some government funding. The other part is if there is that partnership that's established between companies who can then freely work with each other, it develops the consensus already. And to go to your point, right, I mean, those are the kinds of coalitions then makes it easier to bring new innovative ideas in the standards forums. So I think anything we could do from policy standpoint or government funding standpoint, I think that would be welcomed.
That's great. Mark, I'm not sure if you have anything to add, or we can go to questions.
I'll just add, how about a very short comment?
Please.
We have so little influence in the standards from the military community. We just don't compete with the MNOs. We don't compete with the business cases that were discussed earlier. Mm-hmm. So we track and we are engaged when we need to be engaged to drive certain things. But if there was anything we could ever do going forward that would sort of have that understanding that if we unify and at least try to address some of the things related to national security and public safety, and couple that with the standards, that would be a huge help for our industry.
That's great, thanks.
Can I add one thought?
Yeah, please.
It's going to be consistent with what I've said before, and I don't mean to beat a drum too long, but this has been an incredibly innovative industry since its inception. I think we should be extremely proud of it. I also think we should see that there's a pattern that people speak from their own perspective and that has a life cycle to it, right? We started with some radio companies and some switching companies that figured out how to put a radio and a switch together, like Motorola, Marconi, a whole bunch of really great industrial radio companies in police and public safety, and a bunch of switching companies from Bell Labs to NEC to Ericsson to others, and a switch and a radio comes together, magic, right? It runs its course, it goes to 2G, and the switching companies propose time-based because they're switching companies, and the radio companies propose frequency-based because they're frequency-based radio companies, right? And a new player comes in, Qualcomm, that should never have succeeded and creates a new gold standard, okay? Ugly battles, but it happens, okay? And then the world goes, don't change. We'll figure this out. Ringtones, that's the answer. WAP, that's the answer, right? Brew, that's the answer. And another crazy company comes along and proposes a new standard and you get an Ethernet connection, right? But what I'm trying to say is expect everyone to speak from their perspective. If I was a $30 billion company, I would be entrenched in my own ideas. I'm not any better than anybody else. I just don't have that as an asset, so I'm not playing it, right? We're a disruptive company. We're going to try to bring to the industry a reason to change. We're going to try to bring value. Other companies are going to resist for very legitimate reasons because they want a stable, iterative future. And let's see what happens. I actually think it's a really fun way to play. I don't do it as a reason to be disruptive by nature. It's just we think that the world does need, it's why MU-MIMO is not necessarily working as well as it should right now. It's why the vertical industries have not really embraced 5G as well as it should right now, because there are monolithic architectures that need to be unwired. Open RAN is a tool to do that. I give Diane a lot of credit for driving ORPC. And, but the next 10 years is going to be awesome no matter who wins, because so many people are bringing so much energy to a multi-trillion-dollar industry. I just think it's a hell of a lot of fun. You got to bring your A game and just wish for the best.
I just want to make one observation on that, and that is, you know, some of us that are of the same vintage, we can look back and say, you know, it may not have felt like it's disruption at the time, but the disruption is happening. So, you know, I still remember using fax machines where I was, you know, cranking the handle on the fax machine to send a fax to somebody, right? Some of you remember that too. And how many people use a fax machine today? Probably nobody, right? So the disruption is happening. It does take time. I agree, especially when you bring people from all around the world with different agendas, different motivations, and like you said, you got to get in the ring and fight.
I love that. It's a great time to be in this industry. So we have about 10 minutes left, and I would love to open it up to the audience. Oh, good. I don't even have to prod anyone.
Where's Mitch?
Could you tell us your name and
I'm
you're with?
Irfan Gowri from Open Air Interface Foundation.
Thank you.
And further to what Ian was saying, VIV is a board member, and so is InterDigital and many others in our foundation. And you know, open software, open source software is a very good way to try out some of these new ideas and, you know, to demo them. So, you know, us and our colleagues at SRS who are here as well, which is the other open source project, we are trying to promote this idea with the industry, and industry has supported us a lot. Several of you are board members at our organization, and you know, we'd like to also press the U.S. government to consider that, you know, open source is really a very good tool to, you know, standards take time, as you were saying. So, you know, building things out in open source and showing to the world what they can do is a great way of, you know, promoting or moving forward fast.
Any comments on?
I concur.
Yeah.
We are big supporters of OAI. We use their product, and actually for the research and the proof of concepts that we do in our labs, it's a great source to actually have let's just call it a product which has been contributed by other companies that make commercial software. So from that standpoint, you know, we're really happy with that type of an arrangement. So we support that. Thank you.
Okay, thank you for your work. Sir?
Thanks. Bill Shavodian from T-Mobile USA. I have a question for Ray related to your proposed waveform that, you know, I think it sounds interesting. There was a comment yesterday, if we don't have new spectrum, we don't have 6G, which, you know, isn't quite true because they're still refarming existing spectrum. And one of the big problems we had with going from 4G to 5G, there was something defined called dynamic spectrum sharing, which was supposed to allow LTE and NR to use the same spectrum, but because of some limitations on LTE, it wasn't super efficient, so it hasn't, at least to this time, been super successful. I'm wondering if you've looked at, with the waveform that you're proposing for Cohere, how compatible that is with existing 5G waveforms, and would that be able to coexist in a dynamic spectrum sharing type framework?
Well, I really appreciate the question because the answers, I hope, are all going to be interesting to you. We have made the decision and actually completed the process of porting what we call the numerology of our waveform back to 5GNR. So it will be fully transparent to all of the pilot and signaling architectures of 5GNR, and as a result, it'll be fully compatible with 5GNR, right? Second, with regard to dynamic spectrum sharing, we believe, it's our position, we're participating in this moonshot process. It's going to take a while, but we're participating along with various folks from the DoD supply chain as well as the DoD itself. It's complicated. I don't want to be trivializing how massive this project's going to be, but that's why they called it a moonshot. And we do believe that we can drive fully dynamic spectrum sharing between two disparate users. And one of the reasons, and this gets into the technical stuff that I didn't intend to get into today, but if you look into the delayed Doppler domain and you move to geometry, you buy time. I know that sounds like to a high level of comment, but fundamentally, you slow down from physics to geometry, like the pace of how the reflectors are moving. You can actually see persistently for about 100 milliseconds. Depending on mobility, it may be as low as 50. But as a result, you can move the control plane back into the cloud if you want. Now, that's also controversial because not a lot of operators really want to do that right now, right? So we're not pitching it right now. But if you can move the control plane away from the DU fully, all right, and if you do it with sparse enough information in the delayed Doppler domain that it doesn't kill your front haul and back haul, which also it requires a tremendous more technical discussion between us in order to do that. We believe we have already proven, and we will be part of a process that will prove at a much broader level, because there's a lot of constituencies. And from Mark's point of view, and he's just one company, the warfighter is the priority, right? And having been a warfighter, I appreciate your perspective on that. But there's a massive amount of spectrum that if we could ever figure out how to coexist with it commercially, if you just look at FirstNet as an example of sharing between commercial and public safety users and how seldom the commercial users get preempted and how efficient that use of that spectrum is from a capital and a spectral point of view, there's a lot of reasons to go down that path. So I didn't intend to get into this as far as like a use case in 6G, because this is sort of a use case in spectrum sharing. But the reason why 4G and 5G don't share well is because they have different pilot sequences and control planes, and as a result, they both back off like 30% when they coexist. And as a result, the sum of the parts is not worth sharing, right? But think of how amazing it would have been if you could deploy a 5G base station, fill it with 4G mobiles until the 5G mobiles show up, and just literally coexist. So we've thought about that in advance. It's one of the benefits of moving into the delayed Doppler domain is that you're doing both the control and you're doing both the sensing and the communication in the same fundamental waveform architecture, and it allows you to avoid the fact that sensing is it's the control plane that killed the combination of 4G and 5G and DSS. That's at least our perspective. If others have different perspectives, I respect that, but go ahead. Yes. I hope did that answer your question? Okay.
Hello. Yeah, my name is Sarah, and I'm representing KXB Bioverse. We have done extensive research, and then we came up with a pilot on 6G. And right now, my question to the panel is before I frame my question, it is, I heard that every 18 months, the standards keep changing. Am I correct in this saying?
I think I might have made a reference to that. Let me clarify that, you know, typically the way the process works is, let's say if you take 5G as a technology development, and most people, you know, call it okay, it's a 10-year cycle. Within those 10 years, there are 6 different releases, And so that roughly breaks down to about 18-month cycle for each of the release. And the specification is delivered at that 18 months, which has some features and some capabilities. So it's incrementally built over those 6 releases. That's the full 5G technology.
Yes, because the changing frequency of standardizations comes to they don't anymore standards because they are guidelines rather than standardizations. When we are talking about standards, I think we need to have a standards that address many challenges, and that's where we worked extensively. We have formulated the standardizations, and we are working to present them to the government. And another question I have is, all the time we talk about government should be doing that, government should be doing this, but what private sectors, as we all are, even I'm part of the private sector too. So what we have done and what we are presenting to the government as a standardization or any cohesive, because we talk much about collaboration, but we never collaborate. Unfortunately, that is because we all have our own standards, or we all have our own focus, and we never want to collaborate with other business. That is one of the major challenges that we have, and if we overcome that, I think we found answers to many of what we are talking here. So it's not a question, but it's it's an open and conversation that we can take what the private sector has done or what we are presenting to the government, that the government is compelled to come and join us. We are not doing that.
Okay, thank you for your comments. Let's see, question?
Thank you, Mark. I have a question for you regarding this battlefield scenario where all the base stations are gone, the satellites are gone. So are you looking at using, say, HAPS kind of vehicles like AVAX to put this regenerative architecture in there and doing localized communication within the battlefield? So that is a very good use case for HAPS. Any thoughts on that?
Yeah, absolutely. And there's certain services that are adopting that faster than others. Army in particular is looking hard at that. Yeah, and I think the general philosophy, as I mentioned earlier, we use the term of 5G or 6G bubble. You're going to set up a coverage region somehow. And the architecture you set up within that, HAPS would be a great way to have what would be the equivalent of your core, maybe your mech, maybe your RIC, and then it's serving a number of other, quote, base stations that are distributed within that bubble. But we do view it at all layers, and so it would be, typically we think LEO mostly, LEO, then HAPS, and then all of our aircraft, some of which are like U-2s, et cetera, which flying are roughly at the same types of altitudes, right, 50 to 60,000. And then all the fighters, and then all the drones below that, and then all the way down to on the water, that you could have that sort of core of your network anywhere. But you're right, HAPS is definitely one that's being considered, and it's very practical in terms of power and things like that, much more so than the space layer.
Great, thank you for the question. Well, that is time, everyone. Thank you so much for being such a wonderful audience, and thank you so much to our esteemed panelists for joining us today.